There's a lot of material in Chapter 3, and so I'm going to break it up into two different lessons. So in this part of Lesson 3, we'll talk about the mean, the median, and the mode. We are still dealing with descriptive statistics in Chapter 3. In Chapter 2, we talked about frequency distributions that told us how many observations there were in each category or within a specific range. So now we're going to be talking about measures of central tendency. And central tendency is an attempt to describe what the average variable looks like. And so the way we're going to be doing it with this first part of Lesson 3 is we're going to be talking about the arithmetic mean, or sometimes called the average. We'll also talk about the mode and also the median, and all three of these are trying to tell us what the average observation in the data set looks like. The first measurement we'll talk about is the arithmetic mean, or sometimes called the average. You probably learned to compute an average early on in your grade school years. To compute an average, you learned you just added up all of the values and then divided them by the number of observations you had. And that works. That is the computation we're actually going to use. But in order for us to fully use this in statistics, we got to backtrack just a second and talk about populations versus samples. Remember, a population is literally everything in the group that you are getting ready to study, and a sample is just a subset of that, and I'll explain why that is important in just a second. On the screen now you're seeing a couple of formulas represented. Notice that we have a formula for the population mean, represented with the Greek symbol mu, and we also have sample mean, and we'll use x bar to represent the sample mean. Now if you look at the actual formulas, you'll notice that to compute the population mean, you sum up all the values in the specific variable that you are working with and divide it by n, which is represented in this case with a capital N, which represents the number in the population. The sample mean, represented this time as x bar, is the sum up all the values in x divided by n, a lowercase n, and the lowercase n designates the number within the sample. Now, the formulas are exactly the same for a population and a sample, but it is important that we know where the value came from. That's why we designate each one differently. We're going to be getting into some formulas a little bit later on in which we use different computations for samples and populations. Excel is a great tool when you're working with statistics, and it's very easy to compute the mean in Excel. One simple way to do it is to use the sum, as you'll see in the top example on this screen here, where you sum up all of the values and then just divide it by the number of observations. In this case, we have the sum in K3 divided by 10, giving us an average of the values that you see on screen of $14.29. Excel also has a pretty cool function called the average function, and the average function just lets you average a range of values. So with this illustration, you see the function average, and within the parentheses, the parameters of that function are averaging out A3 through J3. Do realize, though, that Excel does not call this the mean, it calls it the average. Just a quick note about Microsoft Excel, and of course a shameless plug here. We will be using Excel quite a bit through the rest of this textbook. Excel, like I mentioned earlier, is a great tool. If you are new to Excel, I do have some Excel videos on my YouTube channel. We also have some instructional manuals available on Amazon.com, and you'll also find some additional resources on my website, luthermaddy.com. Statisticians and statistics professors love symbols. And so we've introduced you to a couple of symbols already, and you'll be seeing more and more as you go through the lessons and the textbook here, but let's just quickly review the symbols that we've seen so far. So we have used capital N to refer to a population, lowercase n to represent the number in the sample, mean for a population is represented with the Greek symbol mu, and we'll use x bar for a sample mean. And as I mentioned, we're going to see many more symbols as we continue on in statistics. Well, we talked about some symbols. Now let's talk about a couple of more vocabulary words. It's important that we also understand the difference between a parameter and a statistic. Now remember, way back with lesson 1, we talked about two different definitions of statistics, and we'll get into one of those definitions now. So numerical characteristics from populations, such as the mu, such as the population mean, we call those parameters. Statistics are numerical characteristics that are derived from samples. So x bar would be a statistic and mu would be a parameter. Now, going back to that definition, one of the two definitions we talked about, statistics are organized, analyzed, presented, or interpreted quantitative data based on sample data. Then parameters, then, if that's what statistics are, parameters are organized, analyzed, presented, or interpreted data based on populations. When we're working with sample data that is numerically based, oftentimes we'll see a value or two that just don't seem to fit the rest of the values around it. Maybe it's much higher or it could be much lower than those around it. And we call those outliers. And outliers can actually skew the computations that we're working with. The mean especially is susceptible to outliers, and we'll talk about that in this next example. Let's examine this example and see how an outlier can kind of skew our mean a little bit here. So let's assume that your statistic teacher gave all 7 students in the class a new quiz, and all of the students scored as shown. Student 1, 100, and student 2, 68%, and so on. So the professor wanted to know, on average, how did the students do? So he computes the mean. Now, because this is a population, all of the students, we're using mu to represent the score of 72, the mean. We're also using capital N to designate how many students are in the population. Now, we're looking at this, and the professor might think, hey, this is a great test, because on average, we scored 72 points. However, if you look at the results, 6 out of 7 are getting a D on the exam. Student number 1 messed up the whole curve by studying too hard, or who knows what she did. Maybe she cheated. No, I'm sure that wasn't the case. But because of that one student scoring 100%, the entire mean is skewed much higher than it is. The 72 mean does not represent the average value within the test scores. All right, we saw how the mean can be skewed by outliers. Another measurement that we use is actually the median, which is really a locational center point. The median is the place where there is an equal number of values below it and above it. And so looking at this example here, we can see that we've sorted the values from low to high, and that we can see that location number 4, or value number 4, there are 3 values lower than it and 3 values above it. And so using this example, we would say that the median score is 68. And that's much more representative of the actual average score than the 72 that we computed with the mean. It's not nearly as affected by outliers. Again, median location is just a location and then the value related to that location. In our first example, we had an odd number of observations, and so finding the median was very, very easy. We simply took, in that case, location number 4, the value associated with location number 4. There were 3 values lower and 3 values higher. Now, when we're dealing with a data set that has an even number of observations, it's a little bit more difficult, but really not all that difficult. So in this case, let's assume that there is only 6 observations. So finding the middle value is really going to be essentially position 3.5, between position 3 and position 4. So we can find that value very, very easily. Once we find the location of the middle value, which in this case is between 3 and 4, we compute the median by taking the average of the 2 values. So I'm on step number 3 here on this screen. We take 67 plus 68, divide it by 2, we compute the mean of those two, we end up with 67.5. So with an even number, again, you just take the mean between the 2 values that are at that location. So in this case, between 3 and 4, we end up with 67 plus 68 divided by 2, computing a median value of 67.5. And for those of you who are using Excel as a tool to compute your statistics lessons, it has a median function. It's very, very easy to use. You see the example here on your screen. And just a quick reminder that all of the data files that are referenced in my textbook do occur on my website, and you can download them. Another measure of central tendency is the mode, and the mode is simply the value that occurs most often, or we could say the most popular value. So looking at the example you see on this screen, we've sorted the values, and we can see that the one that occurs the most is 88. There are 3 occurrences of the value of 88, so the most popular value in this data set, the mode, is 88. Sometimes we run into situations where there is no one most popular value or one mode. And if you're looking at the test results example that we've been using, you'll notice that there is no one value that occurs more often than the others. We have 2 values that occur both twice, 67 and 68. So in this case, we would actually say that this is a bimodal situation, or the data set has 2 modes. As Excel has many other functions that help us with the descriptive statistics, Excel also has a mode function. However, it's really only helpful when there's only one mode. If there's more than one mode, you might consider using Excel's array feature, and that's a little bit more advanced that I'm going to cover in this textbook. All right, let's briefly sum up what we've talked about in the first part of Chapter 3. We've talked about measures of central tendency. We've talked about the mean, which is numerically the mathematical average. We've talked about the median, which is the locational center point and the value that is associated with that center point, and the most popular value called the mode. And remember, all of these lessons are based on my textbook, Surviving Statistics, which is available on Amazon. And do remember to check out my website for downloadable files, calculators, and other resources.